Hello everyone and welcome back to this Python tutorial series. In today's episode, we're going to learn about reading and writing to files. Reading and writing to files is crucial for data storage, logging, and many other applications. So let's dive right in. And so the key function to working with files in Python is the open function. The open function takes two main arguments that we will focus on for now, and we will cover another one later in the video. And there are four different methods or modes for opening a file. We have R for read, which is the default value. It opens a file for reading and throws an error if the file does not exist. We have A to open the file in appending mode, which will create the file if it does not exist and allow us to write to the file adding on to it. We have W, that is write. It opens the file for writing and it creates the file if it does not exist. And then we have X, which is for create. It creates the specified file and returns an error if the file already exists. It also allows us to write to the file. You can also specify if the file should be handled as binary or text mode. Providing a T will be for text mode and is the default value, so you don't need to include a T. And then we have B for binary, which can be used for something like images. So let's jump right into this. So we'll go ahead and start by having a variable f equals open and then the name of the file that we want to open. This will search for the file relative to the file that is running at the moment. So in this case, it's looking in the directory of files.py, which is right over here. And since the default modes are R for read and T for text, you can provide them here if you want to be explicit, but you don't need to include these. So we can go ahead and just leave these off. And if we do try to run this, we can see that it does throw an error because this file does not exist. We can come over here to the left side and just create this demo file.txt. And here we'll just say this is an example. Save it and go back over to files.py. And we'll go ahead and run this again. And we can see there was no error thrown. So cool, it recognized that the file existed. So once we do this, we can actually read from this file since we are in the read mode. You can do this by doing f.read. This will read all of the contents of the file into one string. So if we go ahead and run this, we can see that it got this is an example down here at the bottom, which is inside our demo file.txt. You can also optionally pass in an argument to specify the number of characters to read from the file. So in this case, if we say 5 and go ahead and run this again, we can see that it only got this and then a space after that since that is 5 characters. So if we don't know how long each line is and we just want to read one line at a time, we can use the read line function. So doing this, we can go ahead and run this, and it gets that this is an example. If we come back over to our demo file.txt and we say apple and orange, just to show there's more than one line, we'll go ahead and run this again, and it is just printing one line at a time, and there is an extra space it's printing here because of the new line character. But if we go ahead and Control-C, Control-V this, and run it again, we see that it is printing this is an example and apple. So it is going line by line in our demo file.txt. We can also use the read lines function to read all the lines in a file and return them into a list. So if we go ahead and run this, we can see that all the lines in the file are in a list of strings. And you can see the new line characters at the end of these two. We can also use the seek command to go to a specific spot within the file. So for this case, let's say we read 2 lines and then we want to go back to the beginning of the file. We can do that by saying f.seek 0 to go back to the first position of the file. And we'll go ahead and print read line again after this. And we'll go ahead and run this, and we can see that it's saying this is an example, apple, and it goes back to the beginning after we seek to 0, that this is an example. And it's generally a good practice to close the file after you're done with it. Files are limited resources managed by the operating system. Making sure files are closed after use will protect against hard to debug issues like running out of file handles or experiencing corrupt data. So we can do this by saying f.close. And to note that Python does automatically close the file when the variable for the file is reassigned to another file. So say for example, when we're having this f equals the first open of demo file and we reassign it to demo file 2, it will go ahead and close this first file. And you can see there are many different ways to read from a file, but it can be quite inconvenient to remember to close the file. Luckily, Python has something useful called context managers, and we can use this to automatically close files after we're done with them. So we can do this using the with keyword, then opening the file in whatever mode we want, as a variable name. So in this case, we're just calling it file. and we can print out file.readLines. Here I've created a different demo.txt file with just this is another example, orange and banana. So back in our files.py file, if we go ahead and run this, we can see that it does just print out everything from the file. So under the hood, what this is actually doing is whenever we're calling this with open as file, it's initializing the file object using the open command, and then we're entering into this context, which is this block of code that we have indented, as it returns this file object, which we're labeling it as file here, and we can access it. And then whenever it's done with this context and we get out of it, it performs this exit and it closes the file for us. There are a lot of cool things you can do with context managers, but we'll go into that in a later video. So we'll go into writing to files now. So instead of the R that you did see here, or having nothing at all, we must provide the W keyword to indicate that we are opening a file to write to it. So once we have this, we're doing file.write to write to the file, and we're saying hello world, and then same thing for hello Zectech. If we go ahead and go over to a demo.txt file, we can see that it already has these contents in here. But whenever we go ahead and run this program, there is no output. But if we go back into our demo.txt file, we can see that has been completely overwritten. And that's because the W treats the file as if it was a brand new nothing in it file. It overwrites anything that's inside. And we can also see that it wrote everything to one line, not two lines like we have it here in two different writes. That's because write doesn't automatically apply a new line character, and we have to add that specifically in order to see it in the file. So adding this \n is a new line character. And whenever we go ahead and run this and go back to the demo.txt file, we can see that it did apply that new line character. We can also write more than one thing using the write_lines function. It does take any kind of iterable in as an input, so whether it's a list, a tuple, a set, or any other kind of iterable. And so here we have contents1 is equal to this list of this is a list with a new line character at the end. And we're opening the demo.txt file in write mode as file, and we're writing lines with all of the contents here. So we'll go ahead and run this, no output, go back into our demo.txt file, and we see this is a list. And note there are no spaces in between as well. And so that is something you can come up here and add spaces if you want to. Another way to open this file is in append mode. And we'll do that by passing this a character here. And we can write to it and it just adds on to the file. So currently in the demo.txt file, we have this as a list. And if we go ahead and run this code, no output, we go to the demo.txt and it has appended text. So it is a nice way to add text to your files without completely overwriting everything in there, like with the opening in write mode. So another mode to open up is in X, which is create. As long as that file does not exist, it will create it, but if it does exist, then it will throw an error. So here we're opening demo2.txt in create mode. As long as this file doesn't exist, it will go ahead and create it and write this to the file. So we'll go ahead and run this, and we see no output, and the demo2.txt was created over here. We'll go and click on it and see hello world's in here. But if we go back into our file and try running it again, it does throw an error saying the file exists. And so this can be useful when you don't want to override an already existing file. So one way you can write this is inside a try except block. Inside the try indentation, we have the with open in create mode as we had before. And then we're accepting this file exists error saying that the file already exists. So whenever we go ahead and run this, we can see that the file already exists, and that way it won't end the program. And we can continue on with whatever else we want our program to do. And so if you do need to open a file in binary mode, we can pass this B here right next to this R. You can do the same thing for writing. You can just have write B. You can have WB or AB or XB. But we'll leave it as RB for now, and we'll go ahead and run this. And we can see that it does print out the string that is inside the file with a B in front of it, meaning that it is in binary mode. And so here I've created a folder and just named it folder, and I've moved the demo.txt file inside of it. So if we do try running it like this, we can see that it cannot find the directory or file. So in order to get around this, you can either provide just folder, since that's what I named it, /demo.txt, and run this so we see it works. Or you can provide a // just meaning the current directory, and it also does the same thing. And if we wanted to go up a directory, we would do //. So there might be a situation where you're reading from a file and it contains emojis. So if we take a look at our demo.txt file, and we can see we have this rocket ship emoji in here. If we head back to our files.py file, in here we're just opening up the file in read mode and we're getting the content of the file and printing it out. So whenever we go ahead and run this, we can see that it prints out this is a list, appended text, and it has these weird symbols here. This is because it's not encoding the emoji correctly. So we can see in our demo.txt file, this rocket ship emoji turned into these characters. There actually is a way we can get this to print out emojis instead of these weird characters. And so we could do that by coming up to our open function and providing an optional argument called encoding. And we set it to UTF-8. And doing this will convert this strange set of characters into our actual emoji. So whenever we go ahead and run this, we can see that our emoji was actually printed. So cool. And that's it for today's tutorial on reading and writing to files in Python. I hope this has been helpful. Don't forget to like, share, and subscribe for more Python tutorials. I'll see you in the next one.